All right, good morning, kids. This is lesson for day 33. This is our first lesson in this next unit, identifying and graphing sequences. The standards up there. We're going to be recognizing sequences or functions, so we're going to see a lot of similarities. You're going to be like, oh, this is easy. I know you're going to get it today, okay? Sometimes I find recursively, we're going to kind of think about that conceptually today. We're not going to really talk about that a lot, but we'll talk. You'll see why, and whose domain is a subset of the integers. Okay, here's your objective. Okay, so let's read this out loud. Ready and begin.
I will analyze sequences as functions.
Okay, awesome. Okay, so a sequence. Let me remind you what a sequence is. You all know what a sequence is. I'm sure of it. So like when you were kids, you knew that your even numbers are 2, 4, 6, 8, 10, 12. That's a sequence, right? What do I add to each number every time?
2.
And then what am I starting with?
2.
Does that make sense? Good. So like if I'm like 2, 4, 6, 8, 10, 12. What's the next number?
14.
Next number?
15.
Next number?
18.
Does it ever stop? No, it goes on forever. Good. Or the other idea was like your odds, 1, 3, 5, 7, 9, 11. Next number? Next number?
15.
Good. What am I adding every time on that?
11.
No. Okay, think about the question before I say it out loud. What am I adding every time to the odd numbers? 2, right? Why aren't they the same though? I'm starting with a different number, right? Does that make sense? Okay, awesome. Good. All right, or here's another one. 5, 10, 15, 20, 25, 35.
40.
Good. Those are all easy, right? You all know sequences, yes? So it's like a set of numbers that go on forever that you add the same amount to, or there's like a pattern to, okay? Or here's a harder one. Let's go by 6s. 6, 12, 18, 24, 30, 36.
42. 48.
Gets a little harder, right? Thank you. Good morning. Okay, so those are called sequences, okay? So, sequence, I just described it as a list of numbers in specific order. If you're on the video, you could pause and write this down if you like. A term is each element in a sequence, right? So if I have 2, 4, 6, 8, 10, and so forth, I'm going to put 3 dots after because I'm showing that this goes on forever. Okay, each of these numbers is its own term in the sequence, right? Like 8 is its own term. And the explicit rule, that's the definition there. But it's basically like a math problem that tells us what the number is on each term, okay? So we're going to talk about that today, okay? Okay, here we go. Numbers 1 and 2. Just watch up here, okay? Write the first 4 terms of the sequence defined by the explicit rule. So here's a rule. Hey, doesn't this look like a function to you? Yeah. It's not f of x. What is it? F of n. Good. F of n equals n squared plus 2. Okay, so eyes up here. Eyes up here. I want to teach you because I know a lot of you haven't seen this before. Okay, you've never seen this. Okay, so f of n. So what I want to do when I figure out like my terms, it's saying the first 4 terms. So I'm reading my directions. Write the first 4 terms of the sequence defined by the explicit rule. Here's my explicit rule. Okay, so I'm going to make a table first. So I'm going to make not an XY table, but an N and F of N table. You'll see that? Okay. And it's asking for the first 4 terms. So eyes up here, you just could put 1, 2, 3, 4. You see that?
Yes.
Good. Okay, so F of N, the first one, putting in 1. We got 1 squared is 1. I'll talk right now, okay? 1 squared is 1. 1 plus 2 is 3. Okay? So I'm going to put 3 here. Then I'm going to put 2 in. 2 into where it says n. Okay? 2 squared is 4. 4 plus 2 is 6, right? Next one, 3. 3 squared is 9. 9 plus 2 is 11, right? Next one, 4. 4 squared is 16. 16 plus 2 is 18. Good. Okay? So these are my first 4 terms. So basically, these were my ingredients. Remember functions? Put the ingredients in. What's my output? These are my outputs. You see that? And these are actually the sequence, 3, 6, 11, 18. Okay? 3, 6, 11, and 18. So our answer here, it says the first 4 terms are 3, 6, 11, 18. Does that make sense? Yeah. That's all we're doing, right? Couldn't we keep doing this forever? Yeah, but you could. But I only care about the first 4 in this problem. Sometimes it's going to ask for you for like the 20th term. Sometimes the 100th term. Sometimes it's going to ask you for like the first 5 terms. Or sometimes it's going to say which term is it. So anyways, that's number 1. Okay? Watch me do number 2 over here. Number 2. Okay, same idea. It gives us a rule. So here's our rule. So it's asking the same directions, first 4 terms of the sequence. Okay? So I'm going to make an XY table, but instead I'm going to use n because that's my variable. And then f of n is my function. Okay, putting the same first 4 ingredients in. I want to know what the first one, second one, third, and fourth terms are. So the first term is going to be 1 squared. 1 squared is 1 times 3 is 3. 3 plus 2 is 5. Right? Next one is 2. 2 squared is 4. 4 times 3 is 12. 12 plus 2 is 14. Okay, next one is 3 squared. 3 squared is 9. 9 times 3 is 27. 27 plus 2. Right? 3 squared 9. 9 times 27. Yeah, 27 plus 2 is 29. Good. And then the next one is 4. 4 squared is 16. 16 times 3 is 48. 48 plus 2 is 50. Okay, cool. So then this is a pattern. We'll talk about it if we can figure out the pattern soon. But 5, 14, 29, 15. So it's asking what are the first 4 terms? Well, they are 5, 14, 15. I'm sorry, 14, 29, and 50. Okay? Those are the first 4 terms in that order. Okay? Is this hard? No. It's kind of like what we've been doing, but take an extra step. Okay? So I don't want you to write anything down yet, because I have one more thing to share. But I want you to talk. So let's have students talk for a moment. So there's patterns here, believe it or not. You might not see them yet, but we'll talk about them. Okay, yeah. Eyes up here. So 5, 10, 15, 20. What's the next number?
25.
How did you know that? It's going up by 5s, right? Okay. So check this out. I'm going to erase this this first and second rule. I don't want you to see the rule. What's the next number that should come out after 3, 6, 11, and 18? What should be right here? How would you figure out what should be down here on the next one if I were to get the 5th one? It's kind of hard, right? But I bet we could figure it out. Is there a pattern here? Well, let's talk about it, okay? What do you think the next number should be?
27.
Why?
Because
It goes 3, 5, 7.
yeah, it's gonna go. You're adding 3 to 3 and 5 to 6. 7.
Oh, okay, good. So 27. Let's see if you're right. So again, so what do we add? 3 plus what is 6, everyone?
3 plus 3.
Eyes up here. 3 plus what is 6?
3.
3, good. 6 plus what is 11?
5.
5. 11 plus what is 18?
7.
18 plus what? Oh, I just heard someone say, oh, who said that? You see that pattern? Okay, 18 plus what is 27? Ah, good job. What's the next number then if we see this pattern happening?
37.
Okay, we're going to add 11.
38.
So add 11. The next one should be 38, right? Y'all see that? So do we have to use the rule to figure this out?
No.
No, we don't have to, right? So we can think through that. But there is a rule up here, of course, so we're going to do that. Let's try that one more time over here. So what's the next one after 50? What should be down here? Okay, let's work this out. 5 plus what is 14?
9.
Plus 9. 14 plus what is 29?
11. Or no, 15.
Okay. 29 plus what is 50? What? Okay, do you see a pattern happening?
This is up by 6.
Oh, you see this? 9 plus what is 15?
6.
15 plus what is 21?
6.
Ah, so what's the next one? What am I adding to the next one? 21 plus 6 is?
27.
Okay, so what's the next number? What should it be?
77.
Okay, let's check our work. I want to see if we're right. Okay? 5 squared. Okay, what's 5 squared? What's 5 squared? 25 times 3? 75 plus 2? Isn't that what we predicted?
Yeah.
Whoa, blew your minds. Blood everywhere, right? Okay. I'm just playing. Okay. That was morbid. But no, but seriously, you see how there's patterns in math?
Yeah.
Okay, cool. So today your goal is to not so much look at the patterns, but you should know that they're there. But you should know how to make a table and find the first 4 terms, okay? We've talked already. I would like you to now write quietly for 2 minutes. You're writing down numbers 1 and 2. So I'm going to pause the video here. Here we go on your notes. Number 3, all right? So I'm going to hide number 4, so let's work on number 3. Let's all eyes up at the board. Number 3, we got find the first 4 terms of the sequence defined by the explicit rule. F of n is equal to n cubed minus 1. To your neighbors, describe what you would do as a strategy before you get started. Ready, set, go. What would you do to get going? Okay, good. Let's start doing this, all right? We're doing this one together, okay? So what are we doing, everyone? Make a table, good. What goes on the left side of my table? N, and then on the right side? Good. What are my ingredients I'm putting in here? Or my first 1, 2, 3, and 4. Good. Okay, let's plug 1 in. What's 1 cubed, everyone?
1.
Good. 1 minus 1 is? 0. Good. Okay, keep going here. Finish up the problem. And then I want my answer to be just the first 4 numbers of the sequence on your iPads, okay? I'll give you about 45 seconds. Go. Okay, if I put 2 in, what's 2 cubed? 2 times 2 times 2 is? 8 minus 1 is? 7. Okay, good. Did you get that, Brian? Okay, so 7, right? Next one, 3. 3 cubed is? 27 minus 1? 26. Good. Next one, 4 cubed. What's 4 cubed? 64 minus 1? 63. Good. Okay, so that's not your answer, though. What should you write as your final answer? It should say 0, 7, 26, and 63. Because that's what it's asking. What are the first 4 terms, okay? All right. Thank you. All right. Good job, everyone. That was good. I like the effort I saw everyone putting in there. Let's keep going here. Number 4. Okay, this one's a little bit different, okay? This one's saying the number 125 is a term of the sequence defined by this explicit rule. What term in the sequence is equal to 125? Okay, so this is what it's asking. Eyes up on the board, please. It's saying, like, if we make a table with n and f of n, what term is on the bottom right? Like, what would the number be here? What number makes it equal to 125? Okay, talk with your groups first. I want you to figure out a strategy. How do we know what term that will be? Go.
Oh.
Okay, I'm hearing a lot of great math chat. That is so good. Okay, good. Let me hear some answers. What are some answers? Okay, what are some answers? Let's have someone in the back table. What do you guys think?
You just like go down the list until you get to the number.
Okay, that's a great idea. So you could do this. You go 1, 2, 3, 4, 5, right? And is that what you're thinking, right? Okay, let's put 1 in. Let's put it into our explicit world. What's 1 times 3, everyone? 3. 3 plus 2 is? 5. Good. Okay, keep going. 2 times 3 is? 6. Good. 6 plus 2 is? Good. Okay. That's great. We keep going, right? But we have to get to 125. Is this going to take a while? Yeah, it takes a while. Good. So what's another method we could do? Yeah, back here. Uh-huh.
Subtract 125 by 2 and then divide it by 3.
Oh, you're going to subtract. Why would you subtract?
Because it's adding to.
Ah, okay, good. Raise your hand if you agree with Bernie. Did I say you're not Bernie? Bernadine?
Everyone calls me Bernie.
What would you like me to call you?
That's fine.
Okay, I'm sorry. Okay, Bernadine, let's raise your hand if you agree with her. Okay, cool. So let's look up here. This is what I would do. Eyes up at the board over there. Eyes up at the board. We got f of n. Instead of doing that, let's just put 125 there because that's like our output, right? And then we want to equal to eyes at the board, eyes on the board, 3n plus 2. How would you solve for n here? What would you do? Subtract 2. Isn't that what you guys just described?
Yes.
So we got 123 is equal to 3n. How do you get n by itself? Oh, isn't that what you just told me a moment ago? So n is equal to what? 41, right? Isn't that a faster way to do this than going down the list? Yeah. Now, is it wrong? Is the example said that was shared earlier wrong that you could go down the list and find the answer? No. But does it take a long time? Yeah, because I could say like, oh, what's like what sequence or what's the number for the sequence or term for like 1,246,378? Well, that would take a long time, right? So we would use this method. Okay, so we don't want to write down number 4 yet. I would like you to talk about it. So let's have twos or next. Twos are talking to the rest of the group about number 4. And if there is no 2, let's have a 3 talk. And if there is neither of those, let's have anyone talk. Okay, go. Okay, so everyone's writing down number 4. We're going to pause here just to write that down. I'm going to do a little bit more practice. Continuing on, number 5. Okay, which says got to practice number 1. Let's see if you can do this one on your own, okay? This is like 1, 2, and 3. You're working this out in your notes first. Notes first. Notes first. You're writing this down in your notes. Writing this down in your notes first. And then putting your final answer on your iPads, okay? I've been get distracted, so I want to make sure that everyone gets the opportunity here. So you got n and f of n. You should have drawn a table. And you should have written 1, 2, 3, and 4, and then we're plugging the numbers in. So 1 squared is 1. 1 minus 5 is negative 4, right? Next one is 2 squared. 2 squared is 4. 4 minus 5 is negative 1. 3 squared. 3 squared is 9. 9 minus 5 is 4. Last one, 4 squared is 16. 16 minus 5 is 9. Okay? Oh, no. 16 minus 5 is 11. I don't want to put 9. Fake out. Okay? So... then those are our first 4 terms, so now we're going to just write these down as our negative 4, negative 1, 4, and 11. Those are our first 4 terms. Okay? Make sense? Cool, let's do another one. Last one. Okay, this is like number 6, okay? Okay, let's read this one carefully before we start. Find the 15th term of the sequence defined by this rule, okay? Is it asking for the first 4 terms? No, so should we be worried about like doing a table with like 1, 2, 3, and 4 like this? Should we do that? No, we don't need to do that. How about we just do 15? What happens if you plug in 15? That's what it's asking for. What happens when you plug in 15? Okay? This one should go very quickly, so give you 30 seconds to write and then write the answer down in your on your iPads, okay? I'll give you another 30 seconds. So 1 minute in your performance. So, okay, 15th term. So you should have had this. What's 4 times 15, everyone? 60 minus 3? 57, okay? So that is your answer. So the 15th term, or I saw someone do this. I think Brayden did this. He did f of 15 is what? 57. So that's really a good way to write this. I like the way he wrote this because it's like you're saying the 15th term is 57. It's got like some meaning to it, okay? Okay, that concludes the lesson. So